We present our new method for segmenting maps from different modalities. Humans are pretty good at understanding maps. We are able to naturally understand the topology of very different types of maps, for example, floor plans, emergency maps, maps built by robots, or maps drawn by other people to give us directions. And we're able to do so even though those maps are all very different. Our MAORI algorithm brings some of those ability to robots. In our work, we focused on two types of maps. Robot build maps, because they are the ones that the robot interacts more with, and sketch maps, since they are a natural interface for interaction with a person. MAORI is able to segment regions such as rooms and corridors in robot and sketch maps, and we have better segmentations than previous work. We identify a flaw in previous method for evaluation of map segmentation and propose to use Matthew's correlation coefficient instead. We also make available a dataset of sketches with two associated ground truths made by two non-expert users. Having an input map, the method uses the layout of free space to find regions in the map. It first creates an image where each pixel value is the diameter of the biggest cycle that can be fitted in free space and contains the pixel. We then remove special regions called ripples out of this previous image, which give us the resulting image. Regions with similar value are then associated together, giving us the final segmented map. We can compare this segmentation to the ground truths and see that they are actually the same in this example. In comparison, two recent methods, the DUDE method by Fermin et al. And a Voronoi-based segmentation by Borman et al. Tend to over-segment the map. As we can see by looking at the layout of free space and understanding how each regions relate to each other, MAORI is more robust in extracting places such as corridors. Here are some more examples of segmentation using MAORI with the corresponding ground truths. In the end, we have better segmentation than the DUDE and Voronoi-based segmentations, on a dataset of robot maps and on our dataset of sketch. The MCC ranges from -1 to 1, with -1 being completely wrong, 0 being guessing, and 1 being a perfect score. MAORI got an almost perfect score on robot build maps and a significantly higher score than the two other methods on a dataset of sketches. We will showcase the segmentation live on our stand when you'll be able to draw on the whiteboard maps and they will be segmented. So don't hesitate to come and ask questions. The project is also available online on GitHub. You only need to scan the QR code that's on the slide. Thank you for your attention, and I hope to see you later.